So the exercises that follow 8.3 deal with geometric sequences. This is our new toolkit. Our toolkit has the arithmetic sequences on it, so we can calculate the nth term of an arithmetic sequence. We can calculate the sum of an arithmetic sequence. And now we know also how to calculate the nth term of a geometric series. We just have our geometric sequence, I should say. We need to know the first term, and we need to know the ratio between each of the terms, and we raise it to the power of n minus 1. So the 12th term, for instance, a12, would equal a1 times r to the 11th power, or n minus 1. Okay, so given that we know that, actually we'll keep this close by because we don't want to forget. We want to pull it in here when we need it. We're going to look at some of these problems here. We're going to start at page 358. And on page 358, if we do all these problems, we'll ace our geometric sequences. Well, let's look at the first one. It says determine if the sequence is geometric, and if it is, find the common ratio. So the common ratio will be common between all terms if it is a geometric sequence. So we just have to figure it out. And the first one's easy, 4, then 12, then 36, so we multiply by 3, and we see here that 36 to 72 is a multiply by 2, so it's not common, therefore it's not geometric. Let's jump down and look at one of these over here. Now, by the way, this is a good time to remind the audience here that multiply equals 1 over divide, and divide, if I could spell it, divide, good thing this is an English class, equals 1 over multiply. So when I talk about multiplying, it's the same as dividing, and if I say that there's a common ratio, it doesn't matter whether you're multiplying or dividing. To explain this stuff a little bit more, if you multiply by 2, that's the same as dividing by a half. If you divide by 2, that's the same as multiply by a half. Dividing and multiplying are coming from the same category, they're the same species. So whenever we say multiply, it could be divide. And the reason I mention that is here, this sequence here, there is a division or going on here. First of all, it's divided by 2. And then it's divided by something else. Then it's divided by something else, or multiplied by something else. So is this common? 1, 2, 3, 4. This looks like an arithmetic series to me. This looks like 1 over n. In each case, it's 1 over n. So this is an arithmetic series. This one here, let's finish off with j. Root 2, root 6, 3 root 2, 3 root 6. This is what we call a nightmare, and that is because it is using roots. But if we remember our rules of roots, we are multiplying this by something to get that. And then we multiply by the same thing to get this. So what works? Here we can see that 2 steps up, this is A1, A2, A3. A3 is 3 times A1. So that's a little clue for us. A4 is 3 times A2. So every time you take 2 steps, it multiplies by 3. So we can reason that it should be a multiple of root 3 times root 3 times root 3. Let's test that out. Root 2 times root 3 equals root 2 times 3 equals root 6. Root 6 times root 3 equals root 6 times 3 equals root 18, which equals 3 root 2. And you get root 18 becomes 3 root 2 because we pulled a 9 out of it, and then we put its square root in the outside. So it's 3 root 2. So we do have root 2 was the first one, then root 6, then 3 root 2, and we multiply that by root 3, and it actually becomes 3 root 6. So this is, in fact, a geometric sequence, and r equals root 3. So those aren't very easy when they're dealing with roots, and it wouldn't be very easy dealing with fractions either. But the question is, are we multiplying the first one by the same thing to get the second one, and multiplying that one by the same thing to get the next one. That's 2/8. No, wait a minute, that's 3/12. And that's 2/12. That's multiplied by 2/3. Because if I multiply 1/4 by 2/3, I get 2/12, which is 1/6. If I multiply 1/6 by 2/3, I get 2/18, which is 1/9. And if I multiply that by 2/3, I get 2/27, which is there. So in this one, it is a geometric sequence, and the common ratio is 2/3. This one, if we take a good look at it, we're using our grade 8 algebra here. That's 3x squared multiplied by something equals that. Well, that is 4 times 3 is 12. Whoops, that slipped. That's 4x squared becomes x4, so that's 4x squared, and y3 shows up, so 4x squared y3. So if we multiply this by 4x squared y3, we do get 48x6 y6, so that's correct. So 4x squared y3 shows up here. That's more complicated, it takes a little while. See if you can do the ones that I didn't do.